Welcome to solverfy.
This is the answer to Chapter 19, problem number 57 from the Smith Organic Chemistry textbook. And this problem says, use the proton NMR and IR spectra given below to identify the structures of two isomers A and B having molecular formula C4H8O2. And so, as always with a problem like this, where we're given a formula and spectral data and asked to come up with a structure, I think that the best way to start is to calculate the hydrogen deficiency index for the formula. And so in this case, it's going to be HDI is equal to 2 times the number of carbons, which is 4, plus 2, minus the number of hydrogens, which is 8, all of that over 2. So we have 2 over 2, or 1. And so we have 1 degree of unsaturation in this molecule. And given that we have 2 oxygens present, I'm going to say that our 1 degree of unsaturation is a carbonyl. And then we probably have a carboxylic acid or perhaps an ester, or maybe not, but that would account for those 2 oxygens. So then when we go and look at the IR, for A, we have a broad peak at 3200 to 3600 wave number. That's always indicative of an OH bond. We have another peak at 2800 to 3000, which is CsP3H. So that doesn't really tell us much. Every molecule is going to have them. And then we have this peak at 1700. And so that is always associated with a carbon-oxygen double bond. So we do indeed have a carbonyl here. That's where our single degree of unsaturation is going to come from. And then we need the NMR data to tell us what type of carbonyl we have and to try to help us put the rest of this molecule together. So we have a 2.2 ppm singlet that integrates to 3. And so this is probably a methyl group, CH3. We have a 2.55 ppm singlet that only integrates to 1. Integrates to 1. We have this OH peak in our IR data, and so I'm going to say that this is probably the OH of an alcohol. And so we have a carbonyl and an alcohol in this molecule, but we don't have a carboxylic acid or an ester. So instead we have a ketone or an aldehyde and an alcohol. So then we have a 2.7 ppm triplet, which integrates to 2. And so this is a CH2. And we have another triplet that integrates to 2 at 3.9. So this is probably also a CH2. And it's split to a triplet, and the signal above it is split to a triplet. And so I'm going to say that this fourth signal, because it's the furthest downfield, is going to be a CH2 with an alcohol on it. So one end of the molecule right now looks like this, I think. So CH2OH. And then that's going to be attached to a CH2 as well. Okay, and then I'm going to say that CH2 is attached to our carbonyl. Okay, and then our carbonyl is going to be attached to the methyl group that we have. And I think that makes sense, right? So the methyl group we know doesn't have any neighbors because it's only a singlet. The 2 CH2s that we have would both be split to triplets, the way that I've drawn this. And and the OH group is there. So yes, this is a good structure given all of this spectral data, and this is actually the right answer here. So again, it looks like this: 1, 2, and the alcohol. So there is our structure for A, with a ketone and an alcohol in it. So now we're going to move to B. So we don't need to recalculate the degrees of unsaturation. It's the same formula, but we can just make a note. Oops, forgot that when I change pages, I have to reselect my color here. So 1 degree of unsaturation. So again, I'm thinking a carbonyl, and then maybe an ester or carboxylic acid, or we could have another carbonyl and an alcohol like we had last time. And so looking at the IR data, again, we see that 1700 wave number peak. That's going to confirm the presence of a carbonyl here, carbon-oxygen double bond. And then the peak from 25 to 3500, that's kind of broad but like weirdly misshapen. That is very characteristic of a carboxylic acid OH. So we'll call this carboxylic OH. And so taken together, these two pieces of IR data are definitely making me think that we have a carboxylic acid. And looking at the NMR data, I'm actually going to skip to the third signal. So this chemical shift, this far downfield chemical shift, 10.7 ppm, anything that, anytime that you really see a chemical shift beyond 10, you should be thinking carboxylic acid. Broad singlet, also characteristic of a carboxylic acid OH, and the fact that it integrates to 1. So this is telling us that we do, in fact, have a carboxylic acid in this molecule. So there's that piece. That takes care of our 2 oxygens and our 1 degree of unsaturation. And so we're left with this peak at 1.6 ppm. That is a doublet. It integrates to 6. And so I'm thinking 2 methyl groups here. So 2 equivalent methyl groups are going to give rise to that. And then we have a peak that is at 2.3 ppm and is split to a septet and integrates to 1. And so the key here is to look at the splitting patterns between these first 2 signals. So these first 2 signals are splitting each other. So we have a signal that integrates to 6 that is split to a doublet, and then we have a signal that integrates to 1 that is split to a septet. So by n plus 1, right, n plus 1 is 2, or 1 plus 1 is 2, which is why we get a doublet for the first signal, and 6 plus 1 is 7, which is why we get a septet for the second signal. So this is a carbon with 3 substituents and 1 hydrogen. And 2 of those 3 substituents are going to be methyl groups. So we can put this together like this. So we have 1 methyl group, our second equivalent methyl group. That's where our first signal comes from. We have 1 hydrogen on this carbon. That's the second signal. And then we have 1 more carbon to assign in this molecule because remember it was C8 or C4. H8O2, and so we can put our carboxylic acid right here. And so this is a good structure for this molecule. So again, it would look like this. And this is the correct answer here. Okay, and so again, I think the way to approach these, start by calculating an HDI, look at the IR information and try to determine what it's telling you about functional groups in each molecule. And then look at the NMR information. And if you interpret it right, it tells you all of the pieces that you have. And then you just need to fit them together in a way that makes sense. And that's the answer to chapter 19, problem number 57.